For applications where phase isolation and electromagnetic interference or EMI reduction are essential, non-magnetic raceways are the preferred choice. Here are some options to consider. Firstly, aluminum conduit. Aluminum is a non-magnetic material that effectively blocks EMI interference. It is lightweight and corrosion resistant, making it suitable for various environments. Aluminum conduit systems are available in rigid, flexible, and liquid-type configurations. Secondly, non-metallic conduit. Non-metallic conduits, such as polyvinyl chloride, or PVC, and acrylonitrile butadiene styrene, or ABS, are inherently non-magnetic. They are lightweight, flexible, and easy to install. Non-metallic conduits are not as mechanically robust as metal conduits, so they may not be suitable for certain applications. Thirdly, fiberglass conduit. Fiberglass conduit is a durable and non-magnetic material that provides excellent EMI protection. It is resistant to corrosion, chemicals, and temperature extremes. Fiberglass conduits are more expensive than aluminum or non-metallic conduits. Fourthly, insulated conduit. Insulated conduit systems, such as metal-clad cable and armored cable, incorporate an insulating layer between the conductors and the raceway. This insulation provides additional protection against EMI interference. Insulated conduits are more expensive than standard conduits. Fifthly, EMI shielded conduit. EMI shielded conduit is specifically designed to block electromagnetic interference. It consists of a conductive layer applied to the interior or exterior of the conduit. EMI shielded conduits are the most effective but also the most expensive option. Although aluminum is a non-magnetic material, it can still generate EMI if not properly installed. Grounding and bonding connections must be carefully considered to minimize EMI. Aluminum is more susceptible to galvanic corrosion when in contact with dissimilar metals. Ensure proper connections between aluminum conduit and other components using approved connectors. Other recommendations include using non-magnetic fittings such as aluminum or stainless steel connectors and maintaining a consistent distance between parallel conduits to minimize crosstalk. Consider using shielded cables within the conduits for additional EMI protection. Finally, consult with a qualified electrician or engineer to determine the most appropriate raceway system for your specific application. The selection of a non-magnetic raceway depends on several factors, including the level of EMI protection required, the mechanical strength needed, environmental conditions, and budget constraints. Aluminum conduit offers a good balance of EMI shielding, durability, and cost-effectiveness, making it a popular choice. Non-metallic conduits are suitable for applications where mechanical strength is not a primary concern and where corrosion resistance is essential. Fiberglass conduits provide superior EMI protection and resistance to harsh environments but come at a higher cost. Insulated and EMI shielded conduits are used in demanding applications where maximum EMI protection is required. When installing aluminum conduit, it is crucial to follow proper grounding and bonding practices to minimize EMI. Grounding ensures that any stray currents are safely returned to the source, while bonding creates a low impedance path for fault currents. Proper connections between aluminum conduit and other components are essential to prevent galvanic corrosion. Galvanic corrosion occurs when two dissimilar metals are in contact in the presence of an electrolyte, such as moisture. The less noble metal corrodes preferentially, leading to joint failure. To prevent galvanic corrosion, use approved connectors that are compatible with aluminum conduit and other components. These connectors typically have a coating or plating that isolates the aluminum from the dissimilar metal. Maintaining a consistent distance between parallel conduits helps minimize crosstalk, which is the unwanted transfer of signals between adjacent conductors. Crosstalk can occur when the electromagnetic fields generated by one conductor induce a voltage in a nearby conductor. The amount of crosstalk depends on the distance between the conductors, the length of the parallel run, and the frequency of the signals. Using shielded cables within the conduits provides additional EMI protection by preventing electromagnetic fields from radiating outside the cable. Shielded cables have a conductive layer, such as a braided shield or a foil shield, that surrounds the conductors and is connected to ground. The shield blocks electromagnetic interference from entering or leaving the cable, protecting the signals from noise and distortion. Consulting with a qualified electrician or engineer is essential to ensure that the selected raceway system meets the specific requirements of the application. An electrician or engineer can assess the electrical loads, environmental conditions, and EMI requirements to recommend the most appropriate raceway system. They can also provide guidance on proper installation practices and ensure that the system complies with all applicable codes and standards, such as the National Electrical Code, or NEC. In summary, selecting the right non-magnetic raceway for phase isolation and EMI reduction requires careful consideration of several factors. Aluminum conduit, non-metallic conduit, fiberglass conduit, insulated conduit, and EMI shielded conduit are all viable options depending on the specific application requirements. Proper grounding, bonding, and installation practices are essential to minimize EMI and prevent galvanic corrosion. Consulting with a qualified electrician or engineer can help ensure that the selected raceway system is safe, reliable, and effective. When dealing with electrical systems, safety should always be the top priority. Improperly installed or maintained electrical systems can pose a serious risk of electric shock, fire, and other hazards. Always follow all applicable codes and standards and consult with a qualified electrician or engineer if you have any questions or concerns. The information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or engineer before making any decisions about electrical systems. Furthermore, consider the specific type of load being supplied through the conduits. For example, sensitive electronic equipment may require a higher level of EMI protection than lighting circuits. In such cases, EMI shielded conduit or shielded cables may be necessary. Also, consider the presence of other potential sources of EMI in the vicinity. If there are other electrical equipment or devices that generate significant EMI, it may be necessary to take additional measures to mitigate the interference. This could include using filters, surge suppressors, or other EMI reduction techniques. Consider the environmental conditions in which the conduit system will be installed. If the system will be exposed to moisture, corrosive chemicals, or extreme temperatures, it is important to select a conduit material that is resistant to these conditions. Aluminum conduit is generally corrosion resistant, but it can be susceptible to galvanic corrosion when in contact with dissimilar metals. Non-metallic conduits are resistant to many chemicals, but they may not be suitable for high-temperature applications. Fiberglass conduits are resistant to both corrosion and temperature extremes. Consider the ease of installation and maintenance of the conduit system. Aluminum conduit is lightweight and easy to cut and bend, making it relatively easy to install. Non-metallic conduits are also lightweight and flexible, which can simplify installation. Fiberglass conduits are more difficult to cut and bend than aluminum or non-metallic conduits, but they are very durable and require minimal maintenance. Consider the overall cost of the conduit system, including the cost of the conduit, fittings, installation labor, and maintenance. Aluminum conduit is generally more expensive than non-metallic conduit, but it offers better EMI protection and durability. Fiberglass conduit is the most expensive option, but it provides superior performance in demanding applications. When comparing different conduit options, it is important to consider the total cost of ownership over the lifetime of the system. A less expensive conduit may require more frequent maintenance or replacement, which can increase the overall cost. In addition to the considerations mentioned above, there are several other factors that can influence the selection of a non-magnetic raceway. These include the size and number of conductors to be installed, the voltage and current levels, the type of grounding system, and the presence of any special requirements or restrictions. It is important to carefully evaluate all of these factors before making a final decision. If you are unsure about which type of non-magnetic raceway is best for your application, it is always best to consult with a qualified electrician or engineer. They can assess your specific needs and recommend the most appropriate solution. Remember that the primary goal of any electrical installation is to ensure safety and reliability. By carefully selecting and installing the right non-magnetic raceway, you can help protect your equipment from EMI and ensure the safe and efficient operation of your electrical system. Do not underestimate the importance of proper grounding and bonding. These practices are essential for minimizing EMI and preventing electrical hazards. Make sure that all grounding and bonding connections are made in accordance with the National Electrical Code, or NEC, and other applicable standards. Use only approved connectors and fittings that are designed for use with the selected conduit material. Mixing different types of connectors and fittings can lead to galvanic corrosion and other problems. Inspect the conduit system regularly for any signs of damage or deterioration. Replace any damaged or deteriorated components promptly. Keep the conduit system clean and free of debris. Dust, dirt, and other contaminants can reduce the effectiveness of the EMI shielding. If you are working with high voltage circuits, be sure to follow all safety precautions. Wear appropriate personal protective equipment, such as gloves and safety glasses. De-energize the circuit before working on it, and verify that it is de-energized using a voltage tester. Never work alone on electrical circuits. Always have someone nearby who can assist you in case of an emergency. By following these tips, you can help ensure the safe and effective installation and maintenance of non-magnetic raceways for phase isolation and EMI reduction. Remember that electricity is a powerful force, and it should be treated with respect. Always consult with a qualified electrician or engineer if you have any questions or concerns. And remember to prioritize safety above all else. A well-designed and properly installed electrical system can provide years of reliable service. But a poorly designed or improperly installed system can pose a serious risk to life and property. Take the time to do the job right, and you can rest assured that your electrical system is safe, efficient, and effective. There are various methods of conduit installation, including surface mounting, flush mounting, and underground installation. The choice of installation method depends on the specific application and the environmental conditions. Surface mounting is the simplest and most common method, where the conduit is attached directly to a wall or other surface. Flush mounting involves embedding the conduit within a wall or other structure, providing a cleaner and more aesthetically pleasing appearance. Underground installation is used when the conduit needs to be buried underground, protecting it from the elements and reducing the risk of damage. Each method has its advantages and disadvantages, and the selection should be based on a careful assessment of the project requirements. Furthermore, be aware that different types of equipment may have specific requirements for conduit installations. For example, some equipment may require dedicated conduits or specific grounding configurations. Always consult the manufacturer's instructions and applicable codes and standards before installing any electrical equipment. Also, be mindful of the potential for future modifications or expansions to the electrical system. It is often wise to install additional conduits or spare capacity to accommodate future needs. This can save time and money in the long run, as it avoids the need to install new conduits later. Consider using color-coded conduits to identify different circuits or voltage levels. This can help prevent confusion and ensure that the correct circuits are being worked on. For example, you might use blue conduit for low voltage circuits and orange conduit for high voltage circuits. Also, document the conduit system thoroughly, including the location of all conduits, fittings, and grounding connections. This documentation can be invaluable for future maintenance and troubleshooting. Keep the documentation in a safe and accessible location. Consider using a conduit fill calculator to ensure that the conduits are not overloaded with conductors. Overfilled conduits can lead to overheating and other problems. The National Electrical Code, or NEC, specifies the maximum allowable fill for different types of conduits. And when pulling conductors through conduits, use a lubricant to reduce friction and prevent damage to the conductors. There are many different types of conduit lubricants available, and it is important to select one that is compatible with the conduit and conductor materials. Be careful not to over-tighten conduit fittings. Over-tightening can damage the fittings and reduce their effectiveness. Use a torque wrench to ensure that the fittings are tightened to the correct torque. In summary, The installation of non-magnetic raceways for phase isolation and EMI reduction requires careful planning, execution, and attention to detail. By following best practices and consulting with qualified professionals, you can ensure that the system is safe, reliable, and effective. And always remember that safety should be the top priority in any electrical installation.